Look closely at the next bee you see. You see a tiny fuzzy insect perhaps gathering nectar, but you are missing the most profound truth. You are looking at the culmination of a shockingly complex career, a creature whose entire existence is a perfectly calibrated sequence of duties. What if I told you the life of a single worker bee is more intricate, more organized, and more critical than you ever imagined? Forget what you think you know about bees. Today, we are mapping the entire unseen journey of one individual worker bee, tracing its path from a helpless larva to a vital elder, unveiling the precise evolution of its purpose. Our journey begins in the perfect hexagonal cradle. The queen, the engine of the hive, has laid a tiny rice-shaped egg. For 3 days it rests and then life truly begins. We witness the rapid growth of the larva. For the first few days, its diet is the ultimate source of nutrition. Royal jelly, a special food secreted from the heads of young nurse bees. Then the diet switches to what's called bee bread, a mixture of pollen and honey. This transition in feeding is crucial. It sets the stage for our worker bee's destiny, differentiating her from a potential queen. The dedication of the nurse bees during this period, feeding thousands of larvae at once, highlights the incredible cooperative nature of the hive. After about 6 days of intense eating, the cell is capped with wax. Inside, the larva spins a cocoon and undergoes one of nature's most dramatic transformations, metamorphosis. The timeline is set and the changes are astonishingly quick. When our bee finally chews her way out, she takes her first wobbly steps into the bustling world of the hive. This is the birth of the newest employee in the world's most efficient factory. The immediate instinct of a young worker bee is not to fly but to clean. Her very first job is to meticulously clean out the cell she was just born in, ensuring it is spotless for the next egg. For the next week or so, she operates exclusively inside the hive's nursery. She transitions into the critical role of a nurse bee, feeding the next generation of larvae and tending to the welfare of the brood. This demands constant attention to temperature control and hygiene. She's also responsible for waste removal, carrying debris and any dead bees outside the hive, a fundamental, early contribution to the colony's health. She and her sisters apply propolis, the hive's natural antiseptic glue, sealing cracks and maintaining a sterile environment. From the moment of her birth, this bee is a cleaning specialist and a dedicated child care provider. Around day 12, our worker bee's body chemistry shifts. Her wax glands activate, signaling a dramatic change in her career path. She is now an architect and a construction worker. Time-lapse footage of comb building reveals the breathtaking efficiency of her innate design skills. She and her cohort create the iconic hexagonal cells that form the structure of their home. She also meticulously processes nectar into durable, lasting honey, dehydrating it by fanning her wings and then capping the storage cells. She packs pollen tightly into other cells, preserving the protein source vital for future generations. This phase is intense, focused entirely on building, repairing, and sustaining the colony's wealth and infrastructure. As she approaches 2 to 3 weeks old, her duties shift again, moving her closer to the hive entrance. She becomes a guard bee. Standing at the perimeter, she patrols the small opening, using her antennae to detect specific pheromones and physically inspect incoming bees to discern friend from foe. She's the living defense system of the colony. This transition represents a shift from internal management to external security, a role that carries immediate peril. If a wasp, a mouse, or a larger predator attempts to enter, the guard bee must be prepared to make the ultimate sacrifice to defend the tens of thousands of lives inside. Finally, typically around day 20, the time for her final and most dangerous career stage arrives, the forager. Her first trips outside the hive are short orientation flights. She maps her immediate surroundings, calibrating her internal compass to the sun and local landmarks. Once ready, she takes to the skies for good. The life of a forager is one of immense physical energy expenditure. She flies tirelessly, collecting nectar for carbohydrate energy and pollen for protein, traveling miles from home for the collective good. This is the most visible yet shortest phase of her life. Over time, her wings become ragged and her energy is gradually depleted by the relentless work. But the forager's job is not just collection, it is communication. When she finds a rich source of resources, she returns to the dark hive and performs the iconic waggle dance. This is a precise geometric language that conveys the exact distance and direction of the food source relative to the sun. Her individual discovery is instantly translated into collective gain, activating hundreds of other bees to fly to the perfect location. It is an incredible display of abstract communication that ensures the entire hive benefits from the work of one. After roughly 40 days of relentless, selfless dedication, our worker bee nears the end of her life. She's moved through at least 5 distinct roles, adapting her biology and skills perfectly to the needs of the superorganism at every turn. Her short life, spent entirely in service, fuels the survival and prosperity of her colony. The intricate social structure of the honeybee is not driven by a rigid hierarchy, but by the perfect, fluid progression of roles undertaken by individuals just like her. Her legacy is the thriving hive she leaves behind, a perpetual cycle of life, death, and dedication that continues unseen just outside our window. Look again at that little bee and realize you just witnessed one of the world's most impressive and complete careers. Thanks for watching. If you found this journey as amazing as I did, please like this video and subscribe for more deep dives into the natural world.